Hello and welcome to the first official episode of Life Safety Explained, and today we're going to be talking about conventional fire alarm panels. So as you guys might know, we have two main types of panels to really think about. We have conventional and we have intelligent. There are some addressable panels that are just addressable, and those aren't necessarily intelligent, but that gets really confusing. Here we have my new Simplex 4004. This is a red cabinet version, as you guys might have known, or might not have known. For a little while I had a 4004 that I never brought to video, but here I've got this one now, and I got myself a little conventional panel here. So we have all the details over here about the panel. We're going to go through that bit by bit, but over here we have the main panel and some different components to it. Now, of course, every panel is going to be different, but the key concepts are the same. So we're going to look at some basic circuits to talk about. It should be noted that all these panels have, generally speaking, both power limited and non-power limited circuits. That is something that I will link up here as a video I did as part of my panel build series. Go ahead and check that out. But for now, I will kind of explain briefly that power limited and non-power limited circuits are not to be mixed together in pipe, but they can be in here. You'll notice that the non-power limited wires are all down here, and that's your AC power, your batteries, and everything like that. And then up here we have our power limited circuits, which includes auxiliary power, our NACs, which stands for Notification Appliance Circuit. A video talking about notification appliances in detail will be coming out later in this series. But we also have our auxiliary negatives. We have any power for 4-wire detectors. We have our zones, and let's go ahead and break that down bit by bit here. So before we power this thing up and actually start having some fun with it in a little demonstration here, I want to talk about the difference between all these circuits. So first of all, let's start with these two. We've got our notification appliance circuits, NACs 1 and 2. You can see everything's clearly labeled on the board. Our notification appliance circuits go to our horns and strobes or bells or whatever else. In this case, the panel puts out 24 volts DC, and this would be a supervised circuit if I had resistors on here. In this case, I currently don't. But this would be that circuit. So these two go to two different circuits for our horn, strobes, bells, etc. Now the zones is otherwise known as the initiating device circuit. In this case, this one's a little interesting because this panel has a shared positive and the negatives are different. And then they also have auxiliary negatives, and I don't really know the details on how that works with this panel. This panel is older. It's a little different. I don't necessarily see an assembled on date exactly right here in front of me as of right now, but I'll try to find out in another video, kind of going over this panel specifically. Generally speaking, though, our NACs have a positive, our IDCs have a positive and a negative, and when those short, that's how conventional panels know to go into a latching alarm, unless otherwise supervised or programmed to reset differently. Now, conventional panels have different forms of programming. Many of them just have little dip switches hiding around somewhere This one does not. This one is programmed using the two little LCDs we have here. This one will put out a number which corresponds to this whole programming list. So the number on the left in the alarm zone will show up here, and the number on the right will be whatever section you want. So that's how this menu works. But again, some are dip switch settings, some of them have a full menu, kind of like my 9200 UDLS. It all depends on the manufacturer of the panel, when it was made. Many modern conventional panels now have a more detailed user interface. Okay, so the panel was just powered up here, and instantly I was hit with a few troubles. In this one, it's not super clear exactly what those are without going to look at the instructions here on the left, and I'll show you that in a second. But some panels have just instructions down here, that, or LEDs down here, that would say, for example, battery trouble, or so on. And if it has a full LCD, like the newer panels, then it would show exactly what that trouble is. In this case, it's showing 1, 2, D, and that's it. Oh, E and F as well. So if we look over here, this is what tells us what those troubles are. 1 through 8 is the IDCs. 1 dot through 8 dot, which is not what I have, is the aux output, which is not something that's affected right now. We have no annunciator, no alarm aux. We have D next, which is depleted or disconnected battery, and then NAC 1 trouble and NAC 2 trouble. The reason all these NACs are in trouble is because I don't have a resistor on anything. So what I've got here to kind of show off exactly how this works, like I said, these panels, I said they look for a short circuit, which isn't always the case. These power limited devices, or circuits, are actually looking for an increase in current. Obviously, if you were to completely short a circuit on a panel, it would actually blow up the power supply if it was non-power limited. These, of course, are all power limited. They have to be in order for it to work properly. So what's going to happen is, when I, for example, pull a pull station, it will cause an increase in current up to whatever these, what I assume are resistors, limit it to on the board here. And when the panel sees that current shoot up, that's how it knows to go into an alarm. Furthermore, information upon that will be found in a video that I've already linked before in the panel build series. I can link that down in the description if you guys are interested. As for the NACs, they are generally power limited as well, so they don't blow up if there's a short circuit or anything. However, it can sometimes cause fuses to blow if you're not careful. So, the NACs are pretty simple. As soon as an alarm's detected, it sets off the horns. That's easy enough. And so basically, the power here, on this panel in particular, it's doing a full reversal of the direction of current. So right now our positive is actually negative and our negative is actually positive, and that's how it supervises the circuit with the resistor that would be somewhere at the end of the devices out here. As for our zones, for smoke detectors, they do the same thing. They operate on 24 volts DC, but upon an alarm, it causes an increase in current that the panel sees the same way it would see a pulse station. So I hope that information is helpful enough. Now, to give a demonstration of that and kind of talk about it, I will set up some devices here and we'll make some noise. Okay, to demonstrate the increase in current, like I said, if I were to do a dead short without a power limited circuit, this would make this blow up, which we don't want. This keeps going into trouble reminder, and it's kind of irritating, and seemingly random too. Then this is hooked up as well, because this is the 9236. It's an electronic horn. Last time I tried to use it in a video, It was actually for a request, and unfortunately it wasn't playing nice with me that day due to the damaged little filter I have. So because I've got a simplex panel, I can use it. I think it's set to steady coding, so let's go ahead and pull it. It might not be an instant alarm. Here we go, zone 2 is active. Because I couldn't see its resistor, it's going to do a verification here. And here we go. There it is. Alright, so I can acknowledge, and I can silence, which, oh goodness, acknowledge. C. City tie trouble. Well, that doesn't make any sense at all, considering I have it out of programming. There's no city tie, but the city tie is still hooked up, so that might be part of the issue. It probably tried to make a call out, and it's not happy. Either way, no big deal. Now we would reset our pull station. It went into trouble again, because it still can't see its resistor, because it's an open circuit. However, if I pull again, I believe this panel goes into alarm. Yeah, it's going to go off again, but it's doing verification again, because there's no resistor. Anyway, I'll leave it at that. It's going to be loud. I hope this helped you learn a bit about conventional panels. Conventional panels are definitely fun. Very simple, very easy to wire up. Doesn't need anything special, just some wire and a short circuit, and you've got yourself some alarms going off. So there's that. Guys, thanks for watching. You'll see more of this panel in the future, and we'll have some fun stuff going on with it, and hopefully I can clear some troubles when I put some resistors on there too. For now, guys, thanks for watching. Let me know if you have any further questions below, and I will see you in the next video.